All right, so today's lessons, the first the first thing I want to show you is here's the solutions to Wednesday's work. Now, I've posted a video that shows you how to solve all of these, so please use that as a resource. But these are the solutions, but you can't just turn these in. Uh, you got to show me the work. But this way you have a check. And that's everybody I want to emphasize. The quadratic formula is a very important formula to know because you can solve all these just by using it. And that works for every quadratic. Now, today is still using the quadratic formula. Again, its importance is emphasized by the fact of doing it for 2 days in a row. So let's take a look at how you diagnose how you would solve a problem. With keeping in mind that the quadratic formula solves them all. So this is a quadratic equation. X squared is the highest exponent. There's an x term on the right-hand side, but it's x to the first power. So what you want to do is get this into standard form. So here we go. Let's just add that 8x right there. And the 8x we're going to add to the left side, and we'll stick it right in the middle because that's where we want it. So it's in order from highest exponent, and the next highest, and then the constant 41. And at that point it equals 0 because negative 8x plus 8x is 0. And once you get to that point, you're ready to go. A is equal to 1, the number in front of the x squared. B is equal to 8, the number in front of the x. And C is the constant term, 41. And if you haven't got it memorized yet, here is the quadratic formula. So let's do our substitutions, and let's find the two answers. So we'll go negative, because we always start with that negative, of b, and b in this case is our a, plus or minus the square root of that 8b squared, minus 4 times a, and times c, 41. All divided by 2 times a. We love it when that a value is 1. It doesn't have to be, but it is nice. And now it's just cleanup. Now, I do want to point out this inside, underneath the radical here, it's got a name. It's called the discriminant. We'll talk about that later on. But that you could, if you just type that in to your calculator, it would spit out the correct answer very, very quickly and easily for you. But you type it in just like that. Don't put the square root symbol over it when you type it into a calculator. So let's go ahead and evaluate that. And in case we don't have a calculator because of testing restrictions, it just works like this. You square the 8. Then you do this multiplication, negative times a positive times a positive. So that's going to be a negative. And what is that? That's 4 and 16, so 164, I think. Let's double check that over here. Yeah, 164. So we're good. All divided by 2. And we just keep simplifying underneath the radical. 64 minus 164 is negative 100 over 2. And that is negative 8. I can square root a negative now because I know the imaginary number, and I know the square root of 100 is 10, so it's 10i. And then we just divide everybody by 2. Negative 4 plus or minus 5i. And we're done. Okay, so get the darn thing in standard form. Once that quadratic's in standard form, you know a, b, and c. Once you know a, b, and c, you can use the quadratic formula, and you just have to simplify. So here's our next problem. we'll attack it the same way. Notice again, it is quadratic. I want to get this thing equal to 0, so I'm going to move the 30x and the 25 to the other side. So I subtract them from the right and from the left. So I end up with what's shown here in red. Now, if everything is divisible by the same number, you could simplify this quadratic and you'd still get the same solutions. In this case, what I would like to do, though, is divide everybody by a negative 1. And that just relieves a lot of the negative signs. If there was any other number, if I could divide everybody by 9, for example, I would certainly do that. Or even if I could just divide everybody by 2, I would do that. But I can't. But I could do that, divide by negative 1. And now we know what A is. A is 9, B is 30, C is 25. We go, oh, I'm solving a quadratic, so I grab the quadratic formula. Have that written down on a sticky note somewhere so you always got it and can remember it. And we just start to substitute. So it's negative of B, 30. Then it's going to be that 30 squared under the radical, the B squared, minus 4 times A, which is 9, times C, which is 25, all over 2 times A, and A is 9. So let's work underneath the radical first. Negative 30 plus or minus. I have to do 30 times 30, that's 900. The second part, then I can do this multiplication here. Now, because there's only one minus sign, it's negative 4 times positive numbers here. I know it's going to be a negative answer. So now I don't even have to think about the negative sign. I just have to worry about what is 4 times 9 times 25. You could get your calculator for that, but you can do it in your head pretty easily. Do the 4 times 25 first, that's 100. And 100 times 9 is 900. So it's minus 900. All over 2 times 9, which is 18. And so it's this, plus or minus square root of 0. That 900 minus 900. And while negative 30 plus 0 is still negative 30, and negative 30 minus 0 is still negative 30, so we only end up with one answer. Negative 30 over the 18. And we'll just simplify that. These guys are both divisible by what? 6. So negative 5 over 3. We only ended up with one answer, and that means we have multiplicity. That means this graph, if you look at the other video, I explain it, will touch the x-axis at negative 5/3, and we call that multiplicity of 2. All that means, L right there, all that means is that we consider negative 5/3 a solution 2 times. Hence the reason we call it multiple or multiplicity of 2. And then our last example for today, again, quadratic, x squared, linear term. Ooh, there's another linear term. Well, let's get everything to the left-hand side. I'm going to do this one in steps so you can see them all. I'm going to subtract the 3x and line it up underneath the other x term. And the result is 2x minus 7x squared equals 4. 3x minus 3x is 0. I'm going to subtract the 4 to move it over. And so I end up with 2x on the left, a negative 7x squared, and a negative 4 there. And 4 minus 4 is 0. Now this is not in standard form, so you want to rearrange it. Put the x squared term first, including its sign. Then put the 2x, the next highest degreed variable. Then the negative 4. And again, to make your life easier, I would try and divide everybody by the same number to make it smaller if you can. But in this case, I can just divide everybody by a -1. And all it does is change everybody's sign. 0 divided by -1 is 0 still. And if you can get your equations into the standard form, the problem becomes so much easier. And I shouldn't just stay in standard form because you have to get it in standard form. But if you can get that a value as small as possible and positive, it helps. So a is 7 in front of the x squared, b is -2 in front of the x, c is our constant. And I'm not going to rewrite the quadratic formula. I'm just going to start using it. So we go negative of b, -2. I have to square b, so -2 squared minus 4 times a times c, all over 2 times a. Negative of -2 is a +2, positive. Squaring the negative makes it positive. I've got a negative times a positive times a positive, so it's going to be a plus, a positive, or a minus sign rather, negative. And let's do 4 times 7 is 28, and 28 times 4, 112, all over 14 equals 2 plus or minus square root. Boy, that's going to be a big negative number. 4 minus 112, -108, all over 14. The rest of this we're just simplifying. See if we can shrink that all down just a little bit. So that's 2 plus or minus I, because we're square rooting a negative. And now we got to figure out how to factor 108. Now I'm not sure, but I do know 108 is even. So I'm going to make it 2 times 54. I still can't square root either the 2 or the 54. So I'll just keep factoring. So 54, I'm going to make, let's use 2 times 27. So at this point, I know I've got a pair of 2s, so a 2 will be able to come out. But let's look at that 27. Maybe we're not done yet. That's 2 plus or minus. I'm just going to leave the 2's in there for right now. 2 times 2 times, and 27 I'm going to write as a 3 times 3 times 3. So I factored it all the way down to its primes. And here's what that allows me to do. When I'm doing square roots, I'm looking for a pair. So 2 times 2 is 4. Its square root is 2. So I can just take those pair of 2's, put them outside the radical sign, and make it a single 2 on the outside. And I got a pair of 3's, so a 3 also comes out. So on the outside, I'm going to have the 2 that gets to come out. I'm going to have the 3 that gets to come out. There's going to be this 1 3 that has to stay in, all over 14. And so we've got 2 plus or minus. Well, 2 times 3, that's 6 times I on the outside over 3, all divided by 14. Now, obviously, 2 is not divisible by 14, and 6 isn't divisible by 14, but 2, 6, and 14, they're all divisible by 2. So 2 divided by 2 is 1. 6 divided by 2 is 3. And 14 divided by 2 is 7. And that is our simplest answer that we can write for this problem.